Exo Liquid 2137. Pour water between buckets to make water level equal. For this question, it gives us an n buckets, and that is the initially for each bucket where the water the volume of the water, and we want to make the amount of water in each bucket equal, and you can pour any amount of water from one bucket to another bucket. But the thing is that, however, every time you pour k gallons of water, you split loss percent of k. So that is, if we pour 1 gallon, you loss actually, and we are there loss divided by 100, which you cannot use anymore. And what if we pull out, we'll use 1 minus this one. So that is the rest will add to another bucket. So retain the maximum amount of water in each bucket. So what are we thinking about is for this question, right? So the pour, we should not we should consider those kind of buckets, which is, for example, we have a final level, right? And some we the final level, for example, is this green line, and initial level, some will be more than this green line, right? Some will be less, right? So what we're thinking about is that we should not pour multiple times. For example, this pour this again, and pour this again, right? And you move out this again, right? So what we're thinking about is that we just pour those kind of water from the one from higher than final level to less than final level, right? So because we pour a multiple the times, the more times we pour out, the more loss we get, right? So what we think about is that we just pour those kind of water more than the final to those kind of less than final. Let's look at the example 127, and the loss is 8. That is means 80% of the water will be lost, right? So the result, final result is 2. It is written double because it said that we are going to put 5 out, right? So 8% will be lost. So there is only 1 poured from this to the bucket 0, right? So in the end, all of the buckets has a level 2. And you see that return the maximum, and answer within 10 to the power 5 minus 5 will be answer accepted. So for this question, how can we do the question efficiently? Is that we know this kind of water in the final level should be greater or equal to the mean bucket, right? And smaller equal to the max bucket, right? So we are trying to see what is the target one, right? Trying to find the target final result. So this kind of find target from some kind of range can give us some hint of the binary search, right? Because that is a very classical binary search pattern that we are looking for some kind of mean and max range. So actually for this question, it is binary search, right? So that means that we are binary search that final result. But for this one, the final result, it's not a search like a int. It is search like a double range, double from min to max, right? So if we know, for example, a target, right, we can write a function whether can achieve this target. So how can we write for example, is valid function to see whether this is achieved? Is that we go through those kind of buckets. If it is more than target, we have, for example, higher bigger one, right? Bigger plus this kind of bucket minus target. And if it's less than target, that is the less plus equal to this bucket target minus bucket, right? And in the end, we need the water we poured out should greater equal to and then minus multiple by those kind of effective pouring, that is 1 minus the loss divided by 100, right? Should greater equal to the water we need. So after this analysis, we can do coding. So we know the double, right? We can have a mean equals double max value, and max equals 0, right? So what we do is that in the bucket in buckets. So main equals max dot main main bucket, and max will be max dot max bucket. And we are doing the binary search that the double possibly start equals mean, right? And equals max. So how can we write for binary search for the double range? We are write like this, right? While start plus one e minus 5, because it said that for the final result, answer within 10 to the power 5 minus 5 will be the answer will be accepted. So we write start plus 1e minus 5 smaller than n. So we are going to have a double mid equals start plus n minus start divided by 2. So we'll say if is valid, right? So that means we can reach this target bucket, which should have loss and mid. Then means we can possibly get a higher average, right? So we'll have start equals mid. Else we'll have n equals mid, right? And in the end, we don't need to worry about the start end, because start end is there in the range 1 to the power 5 range. So we can return either start or end, right? We just return start. And the private Boolean is valid. So we have int bucket buckets int loss double bucket. All right. So we are going to have, for example, double the water we need, right? The water we need, for example, which is less than what we call larger than the average, right? Should be 0, and smaller than the average will be 0, and greater than average, the target will be 0, right? So what we do is that in the bucket. So let's say if this bucket is smaller than target, so smaller one, we should plus equal to target minus bucket. Else the greater one will plus equal to bucket minus target, right? So in the end, we just return greater multiplied by 100 minus loss divided by 100, the greater equal to small. Doing like this, you see this part, the time complexity is O n buckets, right? So this is O n, and this binary search is searching for the max, the max value, right? And for this one, there is an n operation. This is a log max, so the time complexity will be n log max. Write Python code for this as well, right? So Python code should be similar. We are going to have, for example, mean value, okay, equals float int max value was there, right? So for buckets in buckets, the mean value equals mean value in a bucket, and the max value equals max value bucket. So we're going to have start and equals mean value max value. While this start plus 1e minus 5 smaller than n, right? Then we'll have middle equals start. In Python, actually, we can just have start plus n divided by 2, right? We don't need to worry about the bump. Then if it's valid, right? It's valid target. We just need this. Then we're going to have start equals mid, else and equals mid, right? And then just return start. And we need define the is valid. We need a target, right? Target is float, return boolean. So we'll have smaller equals greater equals 0, right? And for bucket in bucket, what we do is that if the bucket is smaller than target, then we'll have smaller should plus equal to target minus bucket, and else we'll have greater plus equal to bucket minus target. In the end, we just return greater multiplied by 100 minus loss divided by 100 should greater equal to smaller. Right? This is IF. Mid.